All right, so I'd like to warmly welcome everybody. My name is Ainsley. I'm a counselor here at AGI. For those who are joining us for the first time, here's a little background on us. So Alzheimer Group is a charitable organization that supports families and individuals living with dementia. Our services include activities for people living with dementia, individual and family counseling, support groups for caregivers, and courses, workshops, and webinars. Our educational initiatives are made possible by the generous support of the Lasner Learning Center and the Lindsay Memorial Foundation. And before we begin, please note that while the chat feature is unavailable, there is a Q&A space for you to ask questions. You may type your questions at any time throughout the presentation, and we're going to take some time at the end to address them. So today we are very honored to have Dr. Karen Lee, Graduate Program Director in the Concordia University Department of Psychology. Dr. Lee completed her doctoral studies in 1996 at the University of Toronto, followed by postdoctoral fellowships at Duke University and the Max Planck Institute for Lifespan Development in Berlin, Germany. She joined the psychology department at Concordia University in 2000 and is presently a full professor of psychology, where she directs the Laboratory for Adult Development and Cognitive Aging. Together with her students, her research focuses on the role of cognition and hearing health in maintaining mobility in old age. Her work is supported by funding from the Canadian Institutes of Health Research, Canadian Foundation for Innovation, Natural Sciences and Engineering Research Council, and Fonds de Recherche de Québec. She's a member of Concordia's School of Health, the Center for Research in Human Development, and the Engage Center for Studies in Aging. Thank you so much, Dr. Karen Lee, for being with us today. I'm going to hand the floor over without further ado.
Okay, well, thank you so much, Ainsley and Molly, who's off screen, for the kind invitation to join you and present some of our research to you. I'm just going to take a moment to share my screen and cross fingers that you are able to see the correct large screen.
Yes, we can see it.
Okay, super. So, yes, and thank you to all who are joining and taking the time to participate in this session today. So, as already mentioned, I work in the Department of Psychology, and I've put up some pictures of our nice campus. And also in the lower left corner, the School of Health Perform Center building, in which we do a lot of the research that I'll describe today. My background and training is in memory and aging research, but you'll soon see that much of my research is multidisciplinary in nature. And for that, it requires a great deal of collaboration. I've got a wonderful multidisciplinary team that helps me do this work. Okay, so we'll start with a little background. You may recall back in 2016, I think this really made the news, that the world passed a really important milestone in demographics, and that is that the proportion of seniors over the age of 65, which is shown in this graph in the green line. You can see that the population is rising in terms of the total percentage of the population. This exceeded the proportion of children below the age of 5, which is shown in the blue line. So that was really kind of the crossing in about 2016, 2017. And you can see that the lines continue to diverge to this day and even beyond in the projected dates up to 2050 here. So this underscores the importance of directing resources, research, and just material resources towards our aging population to maximize quality of life in terms of social, physical, and mental well-being. So I'm showing a graph that is borrowed from the World Health Organization, and it's a kind of a depiction of the human lifespan going from the left of the figure, early life with growth and development, into young adulthood, middle adulthood, and then older age. And what is showing in these two blue lines is what's considered functional capacity. And so the idea is that, of course, in early life, we're developing all sorts of skills and growing that functional capacity to a point where it kind of peaks and levels off in early and midlife. And then there may be a slight decline or perhaps a more rapid decline in older age. And there is this kind of disability threshold that is in very faint blue shading here. And so, ideally, when we're thinking about older age, we want to try our best to maintain functioning, that functional capacity, so that it doesn't dip below that disability threshold. But even if it does, the objective overall of the kind of research that I do with my students is to really try and understand what are the factors that can be used to boost that line, to raise functional capacity. And the other thing I'll point out is that there's a great deal of variation. You can see how divergent those two lines are. And so that's really the $1 million question. What are the things that we need to be considering and addressing to keep everyone functioning as well as possible for as long as possible? Well, let's unpack the idea of functional capacity, or sometimes known as functional ability. It's been defined by the World Health Organization as being socially engaged, looking after oneself, and being mobile, whether that means moving independently or with assistance. So I'd like to just pause and have you think of these photos and think of what are the sorts of activities that you consider priorities in your own life that are more meaningful and rewarding that you'd like to maintain. Well, continuing on with the way that functional ability is defined, in this graphic, what I'm showing is that functional ability is sort of analogous to a plant. It's sort of observable. It refers to what we do and what we can see and reflect on. So it's like the plant that we can see thriving here. Below the surface, there are at least two factors to consider. One is the kind of soil, the environment. And so in this context, we can think of whether the environment is supportive in terms of physical environment and social environment, whether one lives in an age-friendly home, has easy access to transit, healthcare, stimulating activities, whether there's a socially supportive network or not. So that's the environment. And then lastly, we've got this third component named intrinsic capacity. So those are like the roots. What is going on inside the person? And so coming from psychology, a lot of what we focus on in my research team falls into this category of internal or intrinsic capacity. So just to kind of finish up this, the idea of this graphic, it's through the fit or the match of appropriate environmental supports and intrinsic capacities that we can live our best lives. So we're going to drill down a little bit more into intrinsic capacities. And so the definition I've put up here is that it's the composite of all the physical and mental capacities that a person can draw upon. And you can see from the graphic that there are at least half a dozen intrinsic capacities that can be considered. So these domains include vitality, which means your energy levels, visual capacity, how, that's more straightforward, how well you can see, hearing capacity, how well you can hear, cognitive capacity pertaining to thinking, remembering, reasoning, planning, and so forth, psychological capacity, which has to do with mood, and locomotor capacity, which has to do with your postural control, your ability to move through space. So coming back to the activities that we value, I've just put one of those examples up here again, because I think cooking is a great example of something that requires multiple domains functioning all at the same time. So for instance, we might need to keep track of the steps of our recipe, organize the ingredients, stand and move about the kitchen, perhaps reach for tools along the way. We use many of our senses to inform the cooking process. So I think of this as a great example of multitasking, as it requires us to use more than one of these capacities at the same time. And by my research definition, that counts as multitasking. Research evidence shows that these separate capacities, they do all age naturally. They change naturally over time. But we also know that they're very much interrelated as we grow older. So this implies that if a challenge arises in one domain, it can negatively impact other capacities. So for example, having an impairment of vision, hearing, or cognition, we know from research increases one's risk of falling, thus negatively affecting another capacity. On the other hand, a weakness in one domain might be helped or compensated by another domain. So there's good news and bad news as far as those interrelationships. In my research lab, we consider three broad capacities: cognitive, sensory, and motor. And all three of these systems on their own show gradual declines with healthy aging, but also become more interdependent. So I'm going to show you a little bit of evidence of why we know that they become more independent or interdependent, sorry. So what I'm showing here is some images from MRI brain scanning. And so the story behind these images is to illustrate the link between hearing and cognitive function. It's illustrated in this study comparing older adults and younger adults. And they were asked to be scanned, so be in a MRI scanner, while performing a word listening task. So they had to listen to words and just repeat them, but they were also listening in the context of background noise. So it wasn't like a perfect listening conditions. There was some background noise. And what was interesting about the imaging results is what shows up here as these yellow areas or these yellow blobs. And so wherever there's a yellow highlighted area, this indicates a part of the brain in which the older adults showed more brain activity than the younger adults. The blue areas, conversely, are areas more associated with auditory functioning, where the younger adults showed greater activation than the older adults. So in other words, there are these extra areas of activation that only the older adults were exhibiting. And the interpretation there is that those extra brain activations, they're not in auditory brain regions, they're more in cognitive brain regions. So it suggests that older adults are recruiting or activating extra brain regions to cope with hearing declines. So it really is a compensatory pattern. Here's another brain imaging study, but now we're looking at the interrelationships between the cognitive domain and the motor domain. And so in this study, the researchers tested everyone's usual walking speed. So basically asking people to walk a length of a hallway, and they're timed in how they do that at their usual speed. So that information was taken, and then they underwent brain scanning in an MRI scanner. And this time it's a structural scanning. So they were interested in the volumes of different areas of the brain. And the highlighted portion that I'm pointing to here in the front of the brain, we associate typically with cognitive functions like focused attention and memory and problem solving. So interestingly, it was the volumes in these brain regions that were associated with the participants' walking speed. In other words, older adults with larger volumes in these frontal brain regions tended to walk faster. So like the previous example of the listening task, it's these frontal areas that are more often used for cognitive functions, but in older adulthood, they do seem to be relevant for both sensory functioning and motor functioning. So that's really the take home from this slide, that with aging, a good deal of evidence now shows that cognitive brain regions are more active during tasks like listening and walking. So now I'd like to turn to how we study these kinds of interdependence relations in my research lab. So I'd like you to think about going for a walk with a friend. You know, you're doing some kind of motor activity, i.e. walking, and at the same time, you're listening, you're conversing, following along with the conversation. So we can depict this as, you know, the movement task as one thing that you're doing, and the listening and comprehending, that's the audition type activity. That's the second kind of task. So again, thinking back to my definition of multitasking, here it's a good example because we're moving and we're doing some kind of second task. So the evidence points to cognition helping several domains of functioning, as I've just shown you in other research. Um, if the motor and auditory tasks are both kind of borrowing cognitive capacity in old age, then you might think there's greater competition for this cognitive capacity. And indeed, there is a finite amount of cognitive capacity that can be borrowed or recruited to help support movement tasks or help support auditory tasks. We also know that cognitive capacity declines with as a natural part of healthy aging. Um, and especially the types of cognitive functions that are supported by those frontal brain regions that I showed you before. So this creates kind of a scarce resource situation in which we might find that the movement task or the listening tasks are competing for that cognitive capacity during multitasking. So in the lab, what we often do is ask our research participants to put two things together and do them at the same time. So like that walking and having a conversation, here's an example of listening while balancing. And this is a study in which we specifically asked the question of if hearing challenges negatively affect multitasking ability. So the way that we try and ask that question is by testing balancing while listening and challenge the auditory system by adding a noisy background. We always try to do things as experimentally as possible. Sometimes we also add a group of older adults. So in addition to our group of older adults with good hearing, in this study I'll tell you about, we added a group of older adults with hearing loss. So we're kind of going at this research question in two different ways. So a little bit more detail about the study, which was led by my former doctoral student, Helena Bruce. So she tested young and older healthy adults, plus a group of healthy older adults who happen to have mild hearing loss. So we had three groups of participants in this study. And our listening task was the first task, and it was a listening to numbers task over headphones. And in ideal listening conditions, they're listening to those numbers in a quiet background. But then we challenge listening in some of the trials by asking people to do the same task, but we also play some background noise, some kind of multi-talker crowd noise. And importantly, we make sure that we amplify those numbers according to each person's hearing ability. So we pre-test hearing, and then we adjust the volume of the listening task accordingly. The balancing task happened on a moving platform. You can see one of our happy participants here, all covered in sensors, to capture how well people are able to recover from these very gentle movements akin to what you would encounter on a bus or a metro train. But those movements happen at unexpected times. Then there's just a slight movement forward. Um, so we tested both of these tasks singly. And very importantly, the multitasking condition entails performing the listening and the balancing task simultaneously. So what I'm going to show you in terms of results is the listening accuracy. And so on the left half of this panel are the listening tasks under ideal circumstances. And we've got our three groups, our young, older adults with hearing loss. And you can see they're almost perfect in their accuracy on listening. But once we play the same kinds of information in noise, you can see that performance drops, accuracy drops down to 70% for young adults, and even more for both of the old age groups. So what happens when we add the balance task at the same time? These ones are done while people are seated, so there's no standing involved. But the balancing with that moving platform does not really seem to disturb people too much when the listening task is presented in quiet conditions. But where we see the effects of noise, they're more pronounced in our older adults and even more pronounced in our older adults with hearing loss. So this I'm showing is one side of the coin. This is the listening task performance. And for some of the trials, as you know, we had people balancing at the same time. The balance results showed that the balance performance or kind of recovering from that platform movement was only affected by age, but not by having to do the listening task at the same time. So it seems that it's really in the accuracy of listening where older adults with hearing loss were particularly hindered in their performance. So our interpretation of these findings is that for those with hearing loss, multitasking is harder, even if the sounds are amplified and corrected for the severity of their hearing loss. So an implication of this study is, of course, to ensure that everyone is screened, checked for their hearing, and treated for hearing loss. But we recognize that even with amplification that you might get with hearing aids, the ease of listening and accuracy of what you're listening to can still suffer, especially if you're multitasking. Here's another example, and bringing back this example of going for a walk with friends. So you're chatting. Aside from, the kind of noisy background complaints that we get from our research participants sometimes, older adults often report difficulty tracking who said what in a group situation. So this is called spatial listening, when there's more than one talker and you have to follow and focus in on one of those messages and ignore the others. So this is some work that I've done with colleagues at the Toronto Rehabilitation Institute that's attached to University of Toronto. And for it, we use this kind of immersive testing cabin that gives us this virtual reality presentation. And so my former master's student, Victoria Niborovska, led this first experiment with this setup. And the listening task that I'm going to describe is, as I said, kind of a spatial listening task where we had more than one speaker. And so the task involved looking at a cue word to know which of three voices was the target sentence to focus in on. So here the cue says Hopper, so it's going to be the central sentence that the person should focus on. And it sounds a little bit like this. Hope you can hear it on your computers. Oh, hang on, let's try again.
Ready, Hopper, go to white 2 now.
So ready, Hopper, go to white 2 now. And the task would be to just say the color and the number of that target sentence. So you shouldn't repeat this information or this information. So, you know, to mimic this idea of listening, spatial listening, and trying to distinguish the target message from other competing speakers, we had to present more than one sentence at a time. So in actual fact, the task sounded more like this, with the three speakers going simultaneously. Let's just get that up.
Ready, Hopper, go to white 2 now.
Okay, so it probably sounded like a real muddle, but in the testing cabin, we've got surround sound, so you can get spatial separation of the three messages. And people, it takes some getting used to, but people can do that. The walking task, as you can maybe see here in the diagram, involved walking on a treadmill that was sort of embedded in the virtual reality environment, so that as people are walking on the treadmill, the visual display makes it feel like you're crossing the street. So the task was indeed called street crossing, going from one sidewalk across the intersection to the far sidewalk. And so what we did in this experiment was also bump up the listening task challenge. In some cases, we'd go through a whole series of tests in which it was always the central speaker that was the target. And then the harder version of the task involved making the location of the target sentence unpredictable. Okay, so we had younger and older adults with good hearing. They performed each of these tasks singly, and then with the critical multitasking condition, we had them doing both tasks at the same time. What I'm showing here are the results of the listening task. So like the last experiment, it's a percent correct, so listening accuracy, or rather proportion correct. And we go from left to right in order of easy to most difficult conditions. So the single messages where they're basically just listening and not having to walk, we get a little bit of an age difference. So older adults are slightly less accurate than younger adults. Same with the sentences where the target speaker location was unpredictable. We get a drop in accuracy, which is understandable. It's definitely a harder task. And here's what happens with adding that walking task. We see that adding the walking task doesn't really seem to faze younger adults very much compared to older adults. But when you have people doing walking and having to locate the target message, that's where you get the greatest drop in accuracy for the older adults. Interestingly, when we looked at the walking behaviors, we had markers on our participants as well, so that we could see how their posture might change with these different challenges. And so what I'm showing here is called head pitch, and effectively what that is how much the person's head is angled forward and downward. So the higher the bar, the more downward the person's head is angled. And you can see that the younger adults really have a very upright, good alignment, meaning there's very little angle or pitch. But for older adults, when they're only doing the walking test, they tend to look down at the ground or the treadmill. And actually, they straightened up a little bit more under those dual task conditions where they had to listen at the same time as they're walking. And it didn't seem to matter so much if they were listening to the easy version of the listening task or that unpredictable, harder version of the listening task. So it seems like with adding that listening task, older adults actually improve in their postural alignment, suggesting that they're prioritizing posture. So they're responding in this way, but it's at the cost of their listening accuracy, which does worsen when you have them multitask. So we've done this kind of research in the virtual reality environment there in Toronto with hearing aid users, and they tend to show more priority in the listening task compared to older adults with good hearing. We've also done a similar experiment with older adults who have subjective cognitive decline. That is, they have memory complaints, but they pass all of the memory tasks, the actual clinical tests, with flying colors. So these are people who are just concerned about their memory changes, and they can do the task, but they prioritize posture, and that seems to worsen. So they have more and more difficulty as the complexity of the task increases. So taking all of this together with the previous experiment with that balancing task, I hope I've illustrated some of the approaches that we've taken in devising experiments that we're trying to make true to everyday multitasking, but in a controlled laboratory setting so that everybody remains safe and there are no falls. So beyond demonstrating that older adults, and especially those with hearing loss, have a harder time multitasking, we've also conducted a number of studies to examine how to improve multitasking. So thinking about this kind of, borrowing cognition in order to support listening activities and support mobility or movement activities, our strategy has been to address this common denominator, namely cognitive capacity. So you can see from these little icons that maybe where I'm heading is to talk about brain training or cognitive training. And indeed, that's where we're heading. So in some of the early work along these lines, I teamed up with my colleague Louis Barrère, who's in the Faculty of Medicine at University of Montreal. And he had devised many years ago a training task that I thought would be really appropriate for trying to improve multitasking. Because on the basis of previous research, it seems that that brain imaging evidence I showed earlier suggests that the cognitive operations implicated in hearing and walking they fall under this category known as cognitive control. So cognitive control functions include things like how well we focus our attention, we switch from one type of information to another, and of course, how well we can divide our attention between more than one task, i.e. multitasking. So this is an example of a training task that we had people do on standard computers or even tablets nowadays. So the first part of it is a basic color identification task, and there are really only two options that people had to respond with. So they were always asked to focus on that central fixation plus sign. And the asterisk is really there as a placeholder that is to be ignored, but the action is above the plus sign. So the task here is always to say, is the top item green or is it yellow? So the person would simply press one response key for green or the other one for yellow and do many, many of these trials, and the computer records the accuracy as well as the response time of the answers. The second component of the task is called a letter task or letter identification, and it's equally simple, but now the action happens below that central plus fixation sign. So the task is just to respond with one key press if the bottom item is a B, and the other key if the bottom item is a C. So there's really just two choices, and you just go as fast and as accurately as possible, and you do a good number of these trials. So those are, I guess, those individual task A, task B. And then the real training comes from the dual task condition, which is a series of presentations where there's a random order of displays. So either you are going to tackle just the color decision or just the letter decision, or in some cases, you see both a colored item above and a letter to decide on below. So that's why we have these little placeholders, because in that dual task condition, you're going to tackle two questions. And so it's through this kind of dual task condition with the unpredictable order of which task you're going to have to answer to that really trains up focused attention and, of course, switching between thinking about the color decision, thinking about the letter decision, or dividing your attention between doing both activities with the same presentation. And we know that younger and older adults, after just maybe 4 or 5 sessions of doing these kinds of tasks, can significantly improve their divided attention performance. So I thought, okay, I know that the evidence is out there for this to be a successful training protocol for older adults. Let's see if we can use this and see some improvements in our multitasking setup. So in an early study, we recruited just healthy older adults age 70 years and up, and we randomly assigned them to undergo that computerized dual task training that I just showed for 5 sessions spaced across about 3 weeks, or they were assigned, half of the people were assigned to a no treatment control. So we had everybody come in to do pre-training assessment and then return after that 3-week period for the post-training assessment. And the assessment entailed doing a balance task or some kind of mobility task with or without a memory task. So we're really looking at that multitasking behavior. So this photo shows our group training. As you can see, everybody's kind of working quietly and independently on their computers. And I think we trained groups of 5 at a time. And here's a picture of one of our participants performing the balance task. So this is a pressure sensitive mat, and she's standing and she's listening to the memory task items, and standing on one leg. And so what we found with this, comparing the before and after training, balance performance, this is an indicator of stability. So if you have a low variability of swaying left to right or mediolaterally, that means that your balance is very good. If you have too much sway, that's considered maladaptive. So those who were assigned to the training group did show a very significant improvement in their sway. So they became better at balancing in this activity. Those who were assigned to the no treatment control, who did not engage in any of that cognitive training, showed very little change from pre to post assessments. So this taking this all together suggests that this type of cognitive training can lead to improved balance control and multitasking. So in a larger study, we used the same training task, and this is now with a much larger Canada-wide team of researchers. We took the same training task and applied it in a study of people with mild cognitive impairment. So they had a diagnosis of mild cognitive impairment, and we assessed them on their cognition and mobility before and after the training. The training phase was 20 weeks long, and we assigned people to either do the combined training, which is that original computerized training plus aerobic exercise. Another group did the exercise and then sort of a placebo cognitive training, just kind of generalized internet lessons. And then finally, another group was assigned to do the general internet lessons and stretching with no aerobic components. So we call that the double placebo condition. So we had people come to the training centers 3 times a week for 20 weeks, and then brought them all back to reassess their cognition and mobility. So here I'm showing the cognition, and what was very exciting to us is these are individuals who have a diagnosis of mild cognitive impairment, and this is showing performance on a standard clinical assessment of dementia severity known as the ADAS-Cog. And so the way to read this graph is, this is time going from left to right here. So from the pre-test to 6 months after, meaning post-training. And so in between those 6 months is when they did their exercise and computer work. And so really exciting to see that the people who were assigned to do the combined training, that is exercise plus cognitive training, seem to improve the most. Seems counterintuitive, but this is a significant drop in dementia severity. Those who did the exercise and the sham cognitive training, so that's the internet lessons, they improved, but not quite as much. But then you see the double placebo group really didn't change much at all. So that tells us that combining exercise and cognitive training showed the greatest benefit. And so we wanted to explore that a little bit more deeply and then bring in the sensory angle. So my students, Rachel Downey, Berkeley Peterson, Neera Mohananthas from University of Toronto, teamed up, and they wanted to use the same data set to ask if the responsiveness to training was particularly beneficial to those who have hearing loss. So there was a subset of the synergic trial participants who also contributed hearing measurements. So we analyzed that subset of 75 people. Some of them were classified as having normal hearing, others were classified as being hearing impaired, and we had other measures of hearing as well. So looking at their multitasking was of greatest interest here. So multitasking assessed before and after the training phase. And here you can see one of the participants on a pressure sensitive walkway that helps us to measure the quality and rhythmicity of their walking. So to understand those effects of training on multitasking, we had people walk and perform a cognitive task, both singly and combined. So similar design as those other experiments. Here, the cognitive activities were naming animals on some trials. Some involved counting backwards by sevens. The walking was a 6-meter path on this pressure sensitive gait mat is what they call it. And then we have the combined multitasking condition. So these assessments were given before and after the 20 weeks of training. And splitting up the 75 people into those with hearing loss versus those with normal hearing, we found, and we're quite excited to find, that the people with the hearing loss actually improved more in terms of their walking speed compared to those with normal hearing. And so the stride time is a reflection of how long it takes to, make those footsteps. So the shorter the stride time, the faster you're walking. So indeed, we see this drop in stride time comparing the pre to the post for those with hearing loss, and really not so much change for those with normal hearing. We do know from more detailed analyses that I won't show in graphical format that other analyses showed those with more severe hearing loss and with more severe memory decline were particularly helped by that combined training condition. That is, we observed that synergic benefit of doing the combined exercise and cognitive training. So those who do have hearing loss, whether it's been treated with hearing aids or not, we had a mixture of people in that group. They all seem to benefit more from that combined training than the other two training conditions. So there are still many more papers in progress being written about that synergic trial, but the data collection was cut short in 2020 due to the pandemic restrictions, unfortunately. So with that in mind, our team got creative about converting the training materials to an online format. So fast forward to 2024 and phase 2 of this project that I'll refer to as Synergic 2. So this is also being led by my colleague, Dr. Montero Odasso at Western University. And we have put everything online, starting with those pre-training assessments and post-training assessments, and then, of course, the training modules themselves that happen 3 times a week. So there's some combination of cognitive and exercise training, and there are online coaches that stay in touch with our research participants throughout the training phase. So you can see the different universities represented here indicate where we're actually recruiting participants for this Synergic 2 trial. So because now, there's a lot of research evidence pointing to the efficacy of multi-pronged approaches to brain health, in Synergic 2, we've also added on counseling to address dietary habits, lifestyle habits like brain healthy diet, sleep disturbances, and vascular and metabolic health issues. So an alternative arm actually features different educational modules, but again, it's multi-pronged. But what's interesting about this format is it's customized to each person's profile of lifestyle habits. And so it's of interest to know whether that customized format is better or worse than that standard training plan that we had before. So very importantly, I want to let you know we are welcoming new participants to Synergic 2. It can be done entirely from home. So you're participating online now, so you have an internet connection, presumably. I am going to be putting contact information on a slide at the end of my presentation. If you or someone you know might be interested in learning more about the study. So the last kind of idea that I want to put across today is that earlier this year, there was a very important publication that came out in The Lancet, which is one of the world's foremost publications for health and medical research. And they issued a report, a commissioned report about the prevention, intervention, and care of dementia. And so, whereas our synergic efforts, our synergic trials focus on older adults with mild cognitive impairment or risk for dementia, there are factors that we should be mindful of that can be implemented or addressed earlier in the adult lifespan. So this group of international experts identified 14 modifiable risk factors. And modifiable means that these are things we can do something about to reduce the risk of dementia, whereas non-modifiable risk factors are things like genetic predispositions. But the newsworthy and exciting take home from this commissioned publication is that if we addressed or eliminated these 14 modifiable risk factors for dementia, we could potentially eliminate 45% of dementia cases worldwide. So the graphic that is shown here, and I apologize, in order to fit the whole lifespan in, the graphic has necessarily a smaller font, but I'll read these out to you. So in early life, low education, poor access to education is a risk factor. But then really interestingly, the bulk of those risk factors crop up in midlife, not in old age, but in midlife. So for prevention, we need to pay attention to things like hearing loss, cholesterol, depression, traumatic brain injury, physical inactivity, diabetes, smoking, hypertension, obesity, and excessive alcohol use. In late life, factors such as social isolation, interestingly, air pollution, exposure to toxins and air pollution, and visual loss also have been identified as important risk factors. So taken together, this is a lot. What can we do with this kind of information? The recommendations that the Lancet Commission authors put forward are fairly straightforward, in my opinion. So engaging in cognitive stimulation regularly, checking and treating conditions such as hearing, vision, cholesterol, hypertension, diabetes, depression, increasing physical activity, reducing alcohol use and smoking, and creating an age-friendly social environment. So it's encouraging in that these are modifiable risk factors. They're not a cure for dementia, but being mindful of these and taking action early is what is advisable based on this Lancet Commission. So this is my wrap-up slide. And so I hope that today I've left you with information that illustrates that with aging, hearing and mobility use more cognitive capacity, which in itself is also changing naturally with age. And everyday multitasking activities require many of those different domains of functioning or those different capacities. On the positive side, targeted cognitive control training using computerized software can improve multitasking, and combining this with exercise seems to be more beneficial, especially with those who have hearing loss and or cognitive impairment. How do we take this from the lab to real life? Well, as with the Lancet Commission recommendations, choosing leisure activities that we enjoy that have mental and physical demands are great ways to put research findings into practice in your regular routines at all points of the lifespan. So with that, I'd like to acknowledge my wonderful collaborators, wonderful graduate students who do so much of the work, and wonderful staff members who keep everything running. I also like to acknowledge my funding sources and the research centers that I'm affiliated with. And here's that last slide with the information, our contact email. And if you are interested, simply send us a message saying that you're interested in the Synergic 2 trial, and we'll get back to you shortly. Thanks very much, everyone.
Thank you so much, Dr. Lee. I do have one email question that was sent in to us, if I may. One of the participants would like to know, how can we continue to follow your research?
Oh, if you Google Karen Lee, so Karenli, it should bring you to the Concordia website. And there's a link. Maybe what I can do, I'm going to have to stop sharing my screen to do this, I think, if that's okay.
Yeah, we can always, if you share it with me as well, we can always send it to all of the participants afterward.
Okay, that'd be wonderful. And I might also then include some contact information for our Engage Center for Research on Aging, which does wonderful work in the community as well.
That would be incredible. Thank you so much.
Mm.
Thank you to all of the participants who came today. Again, Dr. Lee, thank you very much, and we wish you all a wonderful afternoon. Take care.
Thanks for having me.
Of course.